All right, guys. Let me do this one first, since I got it up here. So it's got to be that and that, because I can't integrate this yet. du is, of course,
1 over x.
1 over x. I love it. X. Yeah, the integral of 1 is x, because the derivative of x is 1. Kick ass. So then you got uv minus integral of v du. You got x ln x minus integral of x times 1 over x, which of course is 1, and the integral of 1, like we already saw, is x. Cool. So now you can kind of file that away. You can use that as a known fact, which is kind of nice. Anytime you have an integral and natural log, you can memorize it if you want to. Okay. Let's see if I can squeeze one in here. I think so. I was hoping this one would be kind of straightforward. If you see a polynomial piece, the only time you won't make that u is if the other piece can't be integrated. Does that make sense? Because whatever you make u, you're going to take a derivative, and the rest of it will be dv. You'll have to integrate it.
So we should make our judgment off of what we know how to integrate initially, probably, right?
That's part that goes into your what you're thinking about. That goes into how you make a decision.
Right.
Yes. I love it. That you can do anything to this guy. The x is so awesome, right? It's the only function who is its own slope. It's kind of nifty. Who's going to work? U. So what do you let u equal? Like we just said, x. So du is, thank you so much. And then dv, v equals just e to the x. Is that cool? And then just right. There's a lot of different ways to set this up. I see people doing it in a matrix and bullshit, whatever. I like to do it here because then I can just see u dv is that, just to make sure I picked my chunks correctly, right? But you can do it whatever way you like. Let's see, so uv minus the integral of v du. So then I get that. Yeah. Which kind of has some analogies to this. Isn't that neat? Sort of, not really, but kind of, almost, sort of. Yeah, sure. Okay. You squint. All right, how you guys feeling about this by part situation? Is it better? It's not that much weirder. It's difficult because you already know U sub. So a lot of times the mistake students make is they start to treat by parts like U sub. And you're going to just screw up. Or you just kind of give up. You do a couple things like, it's not going to work, whatever, man. But you just got to keep trying different combinations for the U and the dv. Now, the worst thing in the world is if you miscategorize it as a by parts. So that I understand. And then the last guy, let's see. What was the last guy? Oh, that was the definite integral. Yeah, that's the fun one. All right, let's see. What was it, 1/2 to 1/6 or 1? No, it's totally not the one you're thinking about, Jeff. Pi over 4 to pi over 2 x. Now, obviously, if that wasn't there, yes? If that wasn't, is it pi over 3?
Yeah, the top is pi over 3.
Okay, thank you. Which is good because that would be infinity at pi over 2. Yeah. Let's not bring improper integration into this yet because we don't even know it yet. So we're going to learn later this chapter what to do if either my limits are infinite or my function is infinite at some value in the limits. Oh shit, so that's later. Let's not do that yet. So, sort of like what you just said. I know the integral of that, right?
I did, but I didn't do it that way on accident.
Oh shit.
Yeah, that's pretty bad.
since I know the integral, it makes sense that that's going to be my dv. And then that's really cool because then the other chunk, du, is going to kill it. Guys. So if I let dv be secant squared dx, then what's d?
Tangent.
Tangent. U is x, so du is dx. Okay. And I like, again, you can see there's your original integral, and now you can piece together your ultraviolet voodoo. I'm curious if there's a local band somewhere called Ultraviolet Voodoo. Let's see. Got to get their shirt. So then you get x, tangent x, minus this integral, which some of you guys might have memorized, right? That's the other reason why I like to do it like this, and that's why I had trouble earlier, because I hadn't finished writing all this out. There's my original integral, and there's my new integral, right? Bam, bam. How do I do the integral of tangent if you don't have it memorized? Or maybe somebody looked it up in the book, I don't know. How do you do the integral of tangent?
Sine over cosine.
Yes, you make it sine over cosine. So let's kind of do this on the side. Sine x over cosine x, and then what method works? U sub. Love it. And of course, this is an example of a student's favorite kind of problem, the one that has multiple steps, right? So within this by parts problem, there is a U sub problem. It's just the way it is, right? So if I let u equal cosine, du is sine, so I get the integral of 1 over u du, I get natural log of cosine. Now I saw some of you guys writing it like this. Do you guys see how these are the same? Does anyone understand that those are the same thing?
Can you explain it?
Real quick, okay, good. Jeez, okay. So help me out. This is a good refresher. By the way, I remember one time I had a classroom that had chalk. Back in the day, we had chalkboards, which I kind of miss and I kind of don't. And there was chalkboards all around the room. And the teacher would start over there, and then he would just sort of, so all of us would be scooting our chair, scoot, just watching him go. They're like, what did you do on that step? And he'd go running across the room. Oh, yeah, okay. All right. It was great. Anyway. So I'm nowhere near that. But can somebody remind me, is there a way to simplify this or rewrite this in a certain way? Yeah. So if I have to take the derivative of this, I would first bring the 2 freaking down, because that's a property of logarithms, correct? So if I have 3 ln y, how can I rewrite that? If it can come down, it can go back up. Yeah. Cute. I like it. So what is negative natural log of secant x? Did I put absolute values? Yes, I did. I'm so awesome. Okay. Whatever. So what is this coefficient? This is a -1 coefficient, right?
Yeah.
If I put it up there, it's the reciprocal of secant, correct? Which is?
Cosine.
Okay, I love it. So either way you want to write it. So then we can come back. X tangent x minus natural log of cosine x plus c. Or you can say plus natural log of secant, right? Yes.
It's definite. So
Oh, it's definite. Yeah, of course. Good job, Jen. So I immediately forgot the definite stuff. So here's the way to work with definite stuff. You want to immediately remind yourself that is the result of an integration. It's sort of hidden in the middle here, but you see how that's the result of an integration? So this needs to be evaluated from pi over 4 to pi over 3. This is pi over 4 to pi over 3. So instead of plus c, you can actually just put a pi over 4 to pi over 3 and just do the whole thing. Yes?
U is cosine, so du is negative sine, right?
U is cosine, so du. Oh crap, look at me. I'm terrible.
It just
That's negative,
makes
negative,
it
positive. That is positive. Okay. Got it. So now you just plug that stuff in. Yes?
And then what if you made u sine x? Because then
Well, you's gotta be cosine,
there's
because I need my du to be up top. Yeah. Okay. And now I almost don't care, but you plug it in, pi over 3. Now here's where I am gonna want exact values, right? So what is the tangent of pi over 3? Okay, you guys ready? Real quick. Sine likes y, so sine starts at 0 and grows to 1, correct? It makes sense because as you move, I'm making triangles, and the y side gets bigger and bigger and bigger. That's why if you know sine likes y, it makes sense what the hell sine does. Cosine likes x. Starts off all x. That's why cosine starts off at 1. And then as you put this up, what's happening to the x piece of my triangle? It is getting smaller until it's non-existent. That's why it goes from 1 to 0. In fact, let me show you this. Oh, Jesus. I forgot to move my camera. Sorry. Real quick. Watch this. This is kind of cool. I've probably shown you guys, some of you guys this. Let's just follow sine along. What's sine of 0? 0, because there's a 0 y piece to this triangle, right? What's sine of 30? Yeah, grew just a little bit. What's sine of 45? Let's make this radians, pi over 6. What's sine of pi over 4? Root 2 over 2. Now, real quick, watch. Isn't the square root of 1 equal to 1? Yes? Isn't the square root of 0 equal to 0?
Yeah.
What if I divide it by 2? Isn't it still 0?
0.
Okay. What's the sine of pi over 3? Now it's nice and
Three
big.
over 2.
Rad 3. Huh? So this should be square root of 4 over 2, shouldn't it? You guys see that? Square root of 0 over 2, square root of 1 over 2, square root of 2 over 2, square root of 3. That should be square root of 4 over 2. And what is square root of 4? What's 2 divided by 2? Holy shit. Okay. So again, this is just a quick little way, and it's only because of the angles we chose to memorize, to make special. We just chose those angles to be special, right? This just happens to happen. It's nothing deeper, really, but it's kind of a nifty way to remember. Okay, with all that shit said, okay. What is on top of tangent, of course? If you rewrite it? Sine. So whenever sine is biggest, tangent is biggest. Whenever sine is smallest, tangent is smallest. Sine is biggest closer to 90 degrees. So wasn't this a question about tangent of 60 degrees?
Yeah.
Sine's bigger there. Tangent's going to be bigger. And what are the possible values for tangent? What's tangent of 45 degrees? What's tangent of pi over 4? Start off easy. 1, because that's where sine and cosine are the same, right? The other possible values, since it's sine divided by cosine, would it be rad 3 over 2 divided by 1/2, which is rad 3? Or 1/2 divided by rad 3 over 2, which is 1 over rad 3, which is rad 3 over 3. So, if I asked you what are the possible values of sine for the angles you have memorized, you would say 0, 1/2, rad 2 over 2, rad 3 over 2, 1, right? What are the possible values for tangent? 0, rad 3 over 3, 1, rad 3, infinite, right, or undefined. Those are the ones for tangent. When is tangent the bigger one? When it's an angle where sine would be the bigger one. Do you guys understand? Because sine's on the top of freaking tangent. So when cosine's big and sine is small, because that's the way they work, tangent's going to be small. When it's the other way around, tangent's going to be big. So what's the tangent of 60? It's close to the y-axis. It must be the bigger possible value. Go away. Purple. Okay. Can't use purple anymore. Sorry, purple. It's all right. Cool. And then, yeah, I just did talk to the pen. And then what's the cosine of 60? Cosine likes x. 60 is close to, oh, sorry. Oh, thank you. Okay. Someday I'll actually get a TA just to be a camera person. So what's the cosine of pi over 3? 1/2. So you get the natural log of 1/2. And then you come back, minus pi over 4. Tangent pi over 4 is easy. Maybe. Tangent of pi over 4. 1 plus, what's the cosine of pi over 4? Sorry, minus, because it's minus for the second part. Cosine of pi over 4?
2 over 2.
Rad 2 over 2. And that's good enough. Good enough for government work. So I apologize if your 180 teacher was not big on exact answers for trig functions, because they helped you forget your values. So they're too damn bad. You better remember your damn values. So if you forgot them, get them in your head. I just gave you some ways to kind of think about them. I don't have them memorized like that. If somebody says, what's the cosine of 60? I actually think cosine x, that's far from x, must be 1/2. Poor little cosine scared, way the hell up here. It's 1/2, right? It's like a little turtle. 1/2. It's close to home, it's like a rad 3 over 2, right? Whatever helps. Okay, I love it. I almost got that on camera, I did. Okay. I did a little fast at the end, and I'm sorry, and help me out with my minuses and shit. Okay. Yeah, that was the last one on that paper. Good. All right. So, let's do one more together. All right. How are you guys feeling about biparts? Let me check in again, because obviously there's going to be some definite integration. The nice thing with it is technically you should write this here, because otherwise you're saying that this is just itself. But you don't really have to worry about it till the end. Then you just start throwing the shit in, right? You guys with me? So it's kind of like the last thing you have to worry about is just don't forget it like I almost did. Okay. The trig turtle. I love it. Okay. So let's do one of the weirdest biparts problems together. Here we go. Most biparts problems, they'll either be, the only way that they'll be difficult is you'll pick the wrong u and so forth, or you have to do it several times, right? Like you have an x cubed, you have to make it u 1, 2, 3 times, just to get it to disappear. You with me? We saw that earlier. But this problem, this very simple looking problem, has a major issue. That looks, I mean, if I said give me two really beautiful functions, I mean, calculus wise, you'd say e to the x would be your first thing out of your mouth, and then sine x would be up there, right? I doubt a lot of you guys would say arc cotangent or something, right? Another cotangent. No, probably not. So here's the freaky thing about this. Is there any reason that one of these needs to be u or dv? This is a beautiful example of a problem where it doesn't matter. It really doesn't. So you guys tell me which way you want to do this. What do you want to let u equal?
Sine x.
Sine x.
Sine x, okay. So u equals sine x. So then dv equals, so u is this, dv's got to be the rest of it. Now let me do this. This is going to seem really strange. No, I'm not going to do that yet. Yeah, okay. I'll do that later. Okay, here we go. So then what's du?
Cosine.
Cosine x. dx. And what's v?
U to the x.
E to the x, okay. So far everything seems to be just chugging along beautifully, right? Okay, so let's see what we get. I'm going to write down more than normal. I'm going to write down, here's my original integral, right? And this equals uv minus the integral of v du. Does anyone notice something already? No.
There's no, like neither of them can derive or anything to a constant, so it's probably just going to go on forever, huh?
It could go on forever, but there's one little, we're only going to do one more step, and then we can get the answer after a couple more things. We're going to do one more by parts. And believe it or not, we can get the answer right after that. But does everybody see what he's saying? It feels like you're just going to make you go, and 80 years from now, I'll check in. How you doing? How we doing? Here's my problem, Jeff. It wraps around the world several times. Sorry. Oh my God. What do I have in this? What is this? Oh my gosh. No open flames near this, okay? Whoa, that's good stuff. All right. Now, so it's good to notice that. So if I just gave this to you, it would be really understandable that you would go a little insane. Because you can do something with this that we don't even realize we can do. So it's really cool to see this. So let me do what we were doing earlier. I'm going to pull this guy over here. One thing you do not want to do on this kind of problem is change what u and dv were. You have set something in motion. So what do I mean by that? So let's look at just this guy. And let's see if I can get through a problem without making a mistake. That'll be neat. So didn't we let u equal the trig piece?
Yeah.
So I'm going to do that again. So what's du? Negative sign. And so I'm going to let dv equal e to the x, so then v equals e to the x. Okay, that's all nice and good so far. So then I get uv minus the integral of v du. Du's got a negative, so I'm going to make that plus. Let me see if yes, I did. Yay! All right. I'm always worried when I do this because I don't do this very often. Okay. So watch this. This is kind of cool. Is everybody with me so far? Mm-hmm. This specific problem is weird. I'll be really surprised if I just gave it to you, if anybody saw what to do here, because it's a very strange thing we have to do. We are completely not used to doing what we're about to do. So this is the problem. There's a reason I'm writing it. You'll see in a minute. Then I have minus what we got for this. Now, let me ask you a really strange question. Do you see any like terms up there?
Oh, yeah.
Don't you see another one of these?
Mm-hmm.
So if I add this over, aren't there two of them? So we're doing algebra now. We're solving for x. We're looking for, isn't this our unknown? Isn't this the question? So what do I do when I have the thing I'm trying to solve for on both sides? I pull the shit on the one side. You guys see that?
Yeah.
So if I add this to both sides, as if it was an algebra problem, which is weird, I do get two of these. And then I get this business. Let me write this up here for everybody. Let me make sure. Something seems off, but... Did I miss something? Let's see. What happened, sir?
So when you brought down your second by parts, is it supposed to be an addition before the interval?
Oh, no, because this minus distributes. Thank you, though. I've set up a lot of mistrust in my ability to handle negatives. I understand. So please keep an eye on that for me. Yes, thank you. So let me write it up here. So where are we at? We're at this position here. Two of these equals, here you guys are so excited, e to the x sine x minus e to the x cosine x, right? So then I just divide by 2 and I'm done. Yeah, I should have put a plus c somewhere. I'll just put it at the end. The integral of e to the x sine x dx equals 1/2 e to the x sine x minus e to the x cosine x plus c. Which is really strange. So if you see exponential coupled with trig, you think this could happen, right? So you kind of look for that. Maybe. And it gets a little more interesting if this was like e to the 3x, or this was like sine of 5x or something.
So you do by parts until it matches with.
You do by parts until you see the original question, because now you can pull those together. And everything else is not integrated, so you can actually get the answer. It feels weird. Is that not true?
Yeah.
Does it feel like we actually ever integrated?
Not really.
Not really. A couple little places, but that's barely, right? And somehow we integrated this by barely integrating. It's kind of neat. Yeah, I don't know how you guys feel about that. That is the weirdest by parts type of situation to be in. Okay. Now, with that said, I desperately need you guys to get into the homework and try this, so you can come next time with questions. That sounded like I'm going to let you out. I'm not going to let you out yet. There are certain phrases students pick up on, like, oh, like the phrase next time. Like, oh. So what I'm obviously going to do, I really want you to come with questions from stuff you've tried, because there are specific problems in the homework that get tricky in different ways. Yes?
Speaking of specific questions on the homework that get tricky, if you have time to do a few more, can you make one of them a hyperbolic?
Oh.
Because there's one of those.
Yeah, I mean, okay, so hyperbolic trig. Oh shit, I shouldn't do that. Some of you guys might never have done anything with hyperbolic trigonometry. Is that true? You guys, anybody think you've never seen hyperbolic trig functions? Okay, all right, that makes me sad, but you know, I understand. We get less time to do stuff and instructors have to throw some stuff out. But I'm not going to teach you hyperbolic trig, but basically any function you have. So here's what a hyperbolic trig function looks like, and this is called sinh x. And so tell me, I'm not going to do a whole lecture, dear God, but what are our normal trig functions based on? What shape?
Circle.
I understand, don't worry, you're okay. The unit circle, right? So hyperbolic trig functions based on squares, no, I'm sorry, based on hyperbolas, right? So if I had like a unit hyperbola, and then we have to talk about what the hell that means, and you could do a lot of the same kind of stuff. It just makes different types of functions. And I always forget exactly, let me see if I remember what this is. Is this the one that's plus? I forget. And there's a minus for quotient. So there's another way to kind of represent these. So the calculus of them turns out to be very easy because they're built on exponentials. If you see a function in a question that it seems to be assuming you know what the derivative is, just look that shit up, right? So if you have a physical copy of the book, do you know where the derivatives are in your book? Whenever I get a new math book, the first thing I do is look at the front, look in the back. So if you look in the back, there's a lot of these reference pages, and they have derivatives, they have integrals, it's crazy, they have like geometric rules and so forth. It's kind of silly. A little repository of knowledge. Okay. So I'm not going to suddenly teach you hyperbolic trig. I did assign at least one problem with hyperbolic in it. You just look up the derivative. You just treat it like it's a function. If you're curious, you can look up what hyperbolic functions are. If I were you, I would feel a little cheated. You're like, I want to know what the hell these things are. Anybody ever seen like telephone poles and the cables kind of like making this kind of a shape? That's not parabolic, that's not hyperbolic. It's called a catenary. And the only function that we have that really identifies the shape of this well are these hyperbolic trig functions. It's kind of nifty. Yeah, so that's that. If I wanted to fit the shape, I would use a hyperbolic trig function to fit the shape that a cable makes that's between two poles. That's all I'm going to say. Okay, so thank you. So yeah, get into there and try some out. I want to end tonight. Don't get too excited, because this is going to take a little while. Talking about the next section a little bit, right? I didn't actually have to say that. I could have just threw this problem on the board, see what you did. So let me just throw a problem on the board, see what you do. I'm going to start off nice. start off really nice. Here we go. By the way, side note, don't even write this down. You could probably tell what the answer to this question is by the way I'm going to ask it, but is that the same question? Is that the same question as this?
No.
Nope. What's the difference?
Oh,
Don't say it's missing an x.
Because
The
of
cosine
the
squared.
sign.
There we go. That cosine squared is inside the sine. If I don't see shit after this, it must, whatever's there must be inside of it. Yes? And this is one of those little things that students don't pick up on, and they do everything wrong because they think they assume it's this when it's really not. Okay, so thank God it's not this. That would be really gross. This shouldn't be too bad, I hope. Don't overthink it. Yeah? You have a suggestion or a question? Is it 9th edition? Okay. Yeah, look at the first chapter.
Do you have to use it? I was just gonna take you.
Yeah. That's
Wait.
as long as it's got
It should be
flash.
something more. It
Chapter
should
one.
be, yeah, it should be something more simple than that shit. Yeah.
All right, who's got how to do this?
I don't want to do it backwards, but I put u is cosine squared x. I did dv. other way
See,
around,
I'm being so evil right now. This is not a by parts.
use it.
What do you rule out before you do by parts? It's obviously not like a straight up integral.
Oh,
If the derivative is inside.
It's a u sub. Yeah,
yeah.
right? Is there a function in there whose derivative is in there also?
Yeah.
And this is what sucks. When you learn by parts, you start to realize how it's different from u sub, and then you forget the flexibility of u sub, right? U cosine, right? What's du?
Sign.
Negative sign.
Sign,
Right? So all I'm missing is a negative SIGN, negative sign. So I can make that happen easy, right? Constants don't bother me at all. I can make them show up whenever I need them to. So if I want to rewrite this, I now get, there's du, and this is u squared. So that's the beautiful thing of u sub, is it's not as restricted as by parts is. It can be whatever the shit little piece of the thing it wants to be. That makes it work, right? By parts, this is this, there's that, you don't have that flexibility. That's the main difference. And then what's that?
U 3/3.
Yeah, u cubed over 3, and then u was cosine. All right, okay. Not too bad. All right, let's step it up a bit. Step it up. Let's go to a whole another level. Oh shit, did I get you? Maybe not. Okay, so automatically you can tell, or can you tell, this is going to be more trouble. What's the immediate thing that, why was this one so easy? Because there's only one sign, right? So it's du directly. Let me see if you guys can see how this is going to work. Which one has an odd man out? So like, do you see how this one had the even? So this one's got like a guy who can go with this. Okay, let me see if I can make this make sense. So this guy I could break up like this. He's got the odd guy out, yes? When it's sine and cosine, that's what you're looking for. And let me show you why that makes sense. Because now, what is u going to be to make that du? We still have another problem, but we're slowly getting closer.
Sine.
Yeah, if u is sine, that's u to the fourth, that's du, everything's great. Right? So if u is sine, du is cosine x dx. So everything is beautiful except for this guy. In fact, this is a little rough to write. You probably shouldn't even write it, but it's okay. How do I take care of this guy? And again, just to really hammer this home, the whole point of u sub is just to replace all the x with u's. That's it. That's why it's called u substitution. Is there another way I could accomplish this? U is sine. Can I rewrite this to be related to sine?
Minus last squared.
Yes. So then this is u to the fourth, 1 minus u squared. All right, let me stop. You guys see that?
Yeah.
Since you have the Pythagorean identities, that's what you're going to use for the leftover shit. Did I have any leftover shit for him? No, I only had one of him. The minute I put him with there, I didn't have to worry about anything. Oh, I got extra cosines. Shit, so I'm going to take one of them over there. That tells me what u is going to be. The other leftover crap, Pythagorean identity. Kaplow, right? If it was cosine to the fourth, by the way. So if it would have been 5 to begin with, how would I do that? Let's try that next. Let's see. So this now is easy as shit. I try to be careful about when I say that, but that is easy as shit, yes? What's that? Yeah, let's go ahead and throw this in there. So u to the fifth over 5 minus sine to the 7th, 11th over 7 plus c. Okay. You guys see that? The Pythagorean identities come in and save our ass because I can rewrite it and in terms of what I let u equal. That's the whole point. And I like to use the word shuck. So you shuck one of the cosines off, and then these guys you take care of with Pythagorean identity. Okay. So very quickly, has everybody got that? Let me do one thing. I just don't want to rewrite this whole damn thing. If this would have been a fifth power, this would have been a fourth power. This would have just been this, right? This would have just been this. This would have just been this. You would have had to FOIL that out. Right? No tears. You just freaking FOIL it out. It gives a shit. Right? Not that bad. Are you with me? Yeah. Now, what really, really sucks. Do you understand? How do you tell? See how I look for the odd power? Because that's the one that I have an extra one of, which tells me what I'll let u equal. Yes? That kind of gets everything rolling. What if they're both even? Why, John? Why? Right? So let's start off with an easy one. Sorry. I laugh because I'm wondering what you're thinking in your head when you're like, well, that's the easy one? What the shit? Okay. All right, here. I'll give you a hint. Identities. Not Pythagorean, because all it's going to do is throw the problem down. I mean, do you guys understand you can't integrate cosine squared directly? It's not 1/3 cosine cubed, dear God. Does everybody understand that? Please don't give me that shit. That only works if it's polynomial, right? That's the only time power rule comes into play. Don't get overly excited. Or very often I'll get this kind of thing. I'll get somebody tell me that that's the natural log. There you go, Jeff. That was easy. Does anybody understand what's wrong with this? No? The degree of this has to be what to become natural log? First degree. The second degree. 1 over anything doesn't become natural log, right? So be careful about overgeneralizing some ideas. So, there's an identity that will help us with this. Let me ask you this. Here, let's build this one. Does anyone remember what sine of 2 theta is? Okay. Does anyone remember?
Two sine theta, cosine theta?
Say it again.
So it's
Yeah.
two sine theta, cosine theta?
Yes. By the way, so, okay, quick little, yeah, sure. I'll still let you out a little early. This comes from this, sine of A plus B. All right, so I feel, and I've been looking at some of the responses on the survey, and I understand, it is trig that often troubles us the most. You have got to get those identities in your brain. You have to. So I'm sorry if your pre-calc teacher didn't make you, if your calc teacher didn't make you, and then all of a sudden you got this guy who's like, you should know these damn things. Hopefully I didn't say that. Here's how I remember this. Sine is the nice guy. Cosine is the asshole. What do I mean? I don't know. Oh, sine sees this and says, oh, hey, cosine, let's take turns. All right. There's a plus sign. I'm going to keep it the same. Now it's my turn with the B. It's your turn with the A. Okay, there's sine, the nice guy, right? Does that look familiar to anybody? Cosine is the asshole. Cosine says, me first. Screw you. Got a plus? I don't give a shit. Sorry. The funny thing is, that's the only reason I at first said cosine was an asshole because of this, and then I started to realize cosine is an asshole in almost every situation. So it's like, it just carries. So watch what happens if I let A and B be theta. Let's recover this. If I had sine theta plus theta, that would be sine theta cosine theta, right? A and B are both theta, plus sine theta cosine theta, right? So of course it's freaking 2 sine theta cosine theta. Right? You with me? So what if I do the same thing here? What would cosine of theta plus theta be, which is cosine 2 theta? It would be cosine theta, so cosine squared theta, yes, minus sine sine squared theta. Right? Okay. Any of this sound familiar?
Yeah, kind of.
At the edges of your brain? Okay. So watch this. Watch this. That's still not in a good form to help us. It's almost there. Oh my gosh. Okay. Let me pull this up here. So I get cosine of 2 theta equals cosine squared theta minus sine squared theta. But, for example, what is sine squared? Most basic thing about sine squared, what is it? Pythagorean. We did it earlier.
Cosine squared plus
1 minus cosine squared. Right? Because sine squared plus cosine squared is 1, so 1 minus one of them is the other one, right? So don't I get minus negative, so 2 of these?
Yeah.
So then, can't I solve for cosine squared? Isn't cosine squared equal to this plus 1 divided by 2? Why did I write it like that? I'm used to it being the other way. Let me write it the other way. So it's 1 plus cosine 2 theta over 2. In terms of integration, isn't that easier to integrate than that? Because I can do this and I can't do that, so it's automatically easier.
Yeah.
So watch. So what can I replace this with then? Oh my God. I'm sorry. Okay. So I can rewrite this as, and what I normally do is this. So it's 1 plus cosine 2x, right? Because it's x. And I just put the 1/2 out front. And then what's the integral of 1? holy shit. And what's the integral of cosine? Sine. But the derivative of this would need a 2 out front. There isn't a 2 out front, so there must have been an over 2. When the inside is linear, I don't need help. I really want that to make sense. Integral of cosine is sine. 2x. Oh shit, there should have been a 2 out front. There isn't, so there must have been an over 2 to kill the 2 that would come out. Does that make any? And if you don't like what I just said, just do U sub. It's okay.
Oh, yeah, that makes
You'll
sense.
get there. Where am I at? Plus C. Okay. And distribute, blah, blah, blah. So real quick, for sine squared, do you see how if I had a sine squared? Here, instead of writing this in terms of cosine, I would have just wrote this in terms of sine, and I would have gotten this. And then I can solve for sine squared. I can replace it. Yes? And you'll notice if you look on the trig identity sheet that's up in Canvas, I do have I think it's called the power reduction formulas, because you see how it goes from a second degree to a first degree? They should be explicitly on there if I recall. I hope, maybe? I don't remember. Shit. Okay, so it's one of the ones. By the way, do I have the other? I do. So let me give you this. Let me hand it out and then I'll tell you what this is all about. Oh man, people are so far back here. All right, so this is for everybody back there, yes? So I decided to help you out a little bit. I put the inverse trig derivatives at the top. Right, so that'll be a nice reference. By the way, all these worksheets I give you, if I were you, I'd have them all sitting next to me as I'm doing homework. I'm like, okay, oh shit. It's a good idea. We haven't gone through all of these yet, but I just wanted to lay some groundwork. Do you see how it's all about odd and even, like I said? So if there's an odd, so just looking at the sine and cosine stuff, if one of them has an odd power, that's the one you have an extra one of, right? If they both have an odd power, that's fine. You can pick either one. You like it? Now notice the next form involves tangents and secants, which makes sense. But what's the derivative of secant? That's right. What's the derivative of secant? Secant tangent. I love it. I love it. And what's the derivative of tangent? Secant squared. That's easy. Okay, so that's why, since their derivatives are based on each other, an integral with both in them has specific ways to be done, because they're related just like cosine and sine are. They're related to each other in a little worse way than cosine and sine, but they're still related to each other. Okay. So I feel like I want to stop there. We're going to finish, we'll talk about secant and tangent problems, right? We'll do some really weird ones, and then we'll just keep going in chapter 7. I do want to say this, just to remind you guys, just as you do homework, just turn it in, right? If you get homework done, just turn it in. Please, dear God, don't everybody give me their homework on the day of the test, even though you could. Just go do it. And I think we'll probably have, well, we'll talk about the first quiz. I think we'll have the first, let's do this. You'll be excited about this, I think. All right, I want to give you guys a little bit of time to get back in the groove, but let's do the first quiz a week from today, and it will be on U sub and biparts. This will be, what is today? Thursday. So next Thursday, whatever day that is. What is it? February?
Today's Wednesday.
Wednesday, sorry. I teach a Tuesday, Thursday class. Today is the 2nd? First? Okay, so this will be the 8th? I don't know numbers. Okay. So our first quiz, next Wednesday. U sub will be a review of Calc 1 stuff, and then by parts. So that should give you a decent amount of time to get enough homework done in the by part section to, I try to put the quizzes in a place where it makes sense your homework should be done for that section. Does that make sense? Okay. All right, guys, that's plenty. I'll see you guys next time. Have a good weekend. If you have any questions, come up and see me.